Hello everyone, my name is Gaurav and today I'll be giving a presentation on stroke prediction analysis using statistics and probability, and this presentation is given by team 2 which includes Marco, Gaurav and Nitendra. So the agenda for the presentation is data cleaning, EDA, systematic model selection process and then conclusion. I'll be starting with data cleaning, the most crucial step of data preprocessing. In the world of data science, preparing your data is paramount for building accurate and reliable predictive models. Let's start with dataset attributes and initial inspection. This step is crucial for understanding the variables within our dataset, their data types, and for detecting any initial issues or inconsistencies. Next, we can focus on standardizing categorical value, ensuring uniformity is in categorical features eliminates inconsistencies in data entries, which is critical for accurate statistical analysis. Moving on to inspecting missing values, we first identify and quantify any missing data points across the dataset. Understanding the extent of missing values is crucial for informing how to handle them, whether through replacement methods or deletion. Next, replacing missing values. After identifying missing values, we apply appropriate methods to replace the values. Common strategies involves replacing missing data with mean, median or mode. For example, the missing values in BMI column was specifically imputed with its mean, balancing data completeness with integrity. Now moving on to duplicate check in dataset. This is a vital step identifying if there are any duplicate rows in the data set. If duplicates exist, we delete them to prevent biased results and improve model performance, ensuring each observation is unique. Now moving on to the outlier detection and distribution analysis. Uh, this involves identifying unusual data points that may significantly affect analysis. We use statistical methods and visualizations like box plots, count plots, KD plots, and histograms. For example, looking at the distribution of gender, we see a clear majority in one category, while the hypertension shows most individuals without this condition. These plots help us understand data spread and identify potential imbalances or outlier. From the heat map, we can quickly identify features with strong relationships. For example, age shows a noticeable correlation with average glucose levels and hypertension. These are a couple more of the outlier detections we use to find the number of patients with stroke and the age distribution among them. Finally, the treatment of outliers. One effective method is binning, which converts continuous data into discrete categories, enhancing interpredictability with easier to understand categories like young and old. This process also reduces the impact of outliers, as extreme values are grouped into broader buckets, neutralizing their influence on model learning. In conclusion, data cleaning is a vital process for ensuring the integrity and reliability of datasets. Through systematic preparations, quality checks, and management of outliers, the overall quality of data analysis can be significantly enhanced. Now, I'll be handing over to Marco.
Okay, hello everyone. My name is Marco Gonzalez, and I will continue Gaurav's presentation. In this second section, we'll talk about the EDA, or exploratory data analysis. For that, I have selected 5 different observations or images to explore the data we have used. So with the first one, let me slideshow this. So first, we start with the distribution of numerical features by stroke status. These main 3 plots show us how the age, average glucose level, and the BMI, that stands for body mass index, are the main 3 categories we would use for this analysis. And turn this. For the key insight I can take from this slide is, you can see I have 2 categories: 0, no stroke, and 1 has stroke. So for the age, we can clearly see, comparing to other 2, how as the value of the age goes higher, or older ages, the density of the distribution of the data selected goes higher compared to the other two. That's the main key insight from this part. Moving on, the second category is the distribution of categorical features. Why is this selected? Because I wanted to analyze the different other categories that may not be as relevant on the first three, but still have some importance and can give us some insights. For instance, we have the hypertension and heart disease. When a person who has the heart disease or has heart disease before has a risk or increases the risk of having a heart attack, which makes actual sense, and we can take this as an relevant information. Other than that, the people who have hypertension also have this heart stroke risk that we can consider. Next, let me go to the third, which is the correlation heat map. Here, the key is to identify what is the correlation between numerical values for each of the variables we have used. As you can see, I will focus on this line which has the stroke one, because that's the key variable we are going to study. You can see that the age has by far the strongest positive correlation with stroke among the all numerical features, and that the hypertension, sorry, and the heart disease has also shown a notable positive correlation with stroke. As you can see here, stroke has 0.25, 0.13 in both sides, which also includes the glucose level. Moving on, I have the stroke risk by age. The key insight here is how from the age of 50, the stroke risk jumps all the way up to 25% and having the peak value with age of 80. Last, I wanted to show the relationship between the age and the glucose and BMI regression. A summary, you can see these two graphs. The cluster of stroke patients, these dark blue dots on the right sides, represent the older ages, which also have above average glucose level. At the same time, people who has older ages, like 80, has the BMI index above the average value, which represents this relationship between these parameters. Overall, a summary of findings for the EDA part, we can conclude three things. First, the primary factor is the advanced age, over 50 years old, having the peak of 80. There is a contributing factors like elevated glucose and history of smoking, and we have other key variables like the hypertension and the average glucose level. I will pass to Nitendra to continue with the model selection. Thank you.
Thank you, Gaurav and Marco. I'll continue the analysis with the logistical regression, naive Bayes, and decision tree. So when we performed the naive Bayes analysis, we found like recall and sensitivity is coming as 54, which is showing like poor performance, and accuracy rate is also pretty low. Same thing with the decision tree, it is having good recall and sensitivity value, that is 97%, and accuracy is 92.15%. Whereas for logistic regression, it is showing like best performance and with having the accuracy of 95%. So overall, if we will compare all the models together based on accuracy, precision, recall, sensitivity, and F1 score with ROC and AUC scores, we can see that logistic regression is the clear winner, and it's performing as expected. Here are the confusion matrix for naive Bayes and naive Bayes decision tree and logistic regression tree. So in naive Bayes we can see like type 1 and type 2 error are there, big high, whereas for decision tree it is a bit low, and for logistic regression it is coming as very low. So this is the preferred model we can consider. So same thing for interpretation of the logistic regression. So outcome from the analysis, we can say like significant factors are age and hypertension, where we can because they are having the p-value, age is having p-value is very less, whereas for hypertension it is coming as 0.03115. So if person with the high age and hypertension are more likely to be have the stroke, whereas less age and not having the hypertension is more likely to be have a non-stroke case. So this analysis we can use for mainly for preventing the stroke stroke, and we can utilize this in well-being things. So other factors like heart disease, BMI and all are not so significant because their p-values are greater than 0.05. Yeah. Thank you everyone. Over.